Hello, my Algebra 2 students. It is the review day for Unit 3. So really quickly, let's talk about some stuff that you should know at this point. From day one, the average rate of change, that is synonymous with slope. So if you can calculate change in y over change in x, you should be golden there, all right? If it's a linear function, you should have a constant rate of change or a constant slope. The forms of the line, please make sure that not only do you know both of them, but you know them by name. Because if it says leave the answer in point slope form, you're going to lose credit if it's in a form that's not matching that right there, all right? Parallel lines equal slopes, perpendicular have negative reciprocal slopes. That's some good geometry stuff right there. As for modeling linear functions, make sure you know the steps for modeling, doing the linear regression, excuse me. You're going to notice at the very back of this packet, you guys might have seen already, because we might have talked about it in class, that there's a little reference sheet for the old calculators, and then on the back of that for the new calculators as to how to run the regression. So if you forget, don't worry, that sheet is there to help you, all right? Otherwise, within that stuff, making sure that you understand what the correlation coefficient is and how to interpret how good of a fit the line is based on the R value. Interpolation versus extrapolation. One's not better than the other. It's just that if you interpolate, and the data value is more reliable, or the answer is more reliable because it's within the data that you have. If you extrapolate, it may or may not be reliable depending on how far away from the data it is. Okay. Now inverses, I know we didn't take a day in this unit, but we've already covered it and we did some warm-ups with it. So it is going to be on the test. As for piecewise functions, just make sure you know when to have open circles versus closed circles. And then 3x3 systems. These take a bit of work. There will not be more than one of these on your test, but you still need to know how to confidently solve one of those, right? As for questions to do together, there's plenty that we could do. There's only one I'm going to do, though, on this video, and that is number 5, because it is a commonly asked question. So I figured let's just do it now and get it out of the way. There is not necessarily enough space on the review sheet for you to do all the work, so you might need to grab some extra paper. So I grabbed an extra piece of paper here, actually a little half sheet, and I'm going to do my work for number 5 here. So we've got Steve is driving west on the thruway towards Buffalo. He drives at a constant rate of speed of 62 miles per hour. So he could be coming from like Albany or Syracuse or whatever. It's saying after an hour and a half, he's 221 miles from Albany. So you don't really need to draw out an entire graph for this, although you certainly could. But if you can at least just think of the thruway, all right, Albany's over here. If you're looking at a map, Buffalo's over here. Here's us, Rochester, woohoo, right there. So the idea is he's driving in that direction. And after an hour and a half, he's 221 miles away from Albany. So I'm not going to fib. I don't know exactly where that puts him, but maybe over here-ish. I don't know, something along those lines. Okay. So what I do want you to know is that any word problem, you need to know what X and Y represent. So part A kind of gives it away a little. It says determine a linear function for the distance D that Steve is from Albany as a function of the number of hours, H. So that means in this case, X is really the H value or the number of hours. Y is the D value or the distance from Albany, all right? So right now, an hour and a half after he started driving, he's 221 miles away from Albany. I don't really know per se where he started, but I don't care. So when it says figure out the function, what I need to know is since he's driving at a constant rate, they're telling you in those words that it is a linear function, right? So it's staying constant. So that means that that's 62 miles per hour. That is my rate or my slope that I'd want to have here. So 62 miles per hour. And if you think about what it's saying, the miles, that's your Y, over the hours, that's your X. So change in Y over change in X, right? So it kind of confirms what we just talked about here a second ago. So to be able to write the equation, you need to think about the info they're giving you as a point, because at 1.5 hours, he's 221 miles from Albany. Well, that's an X or an H value. That's a Y or a D value. So they're essentially handing you a coordinate point. So if I know the slope and I know a point, this is a great time to use the point slope equation. So that's y minus y1 equals m times x minus x1. Right? Now, it did say in terms of D and H, so, play the game to switch this around. So 62 and then H minus 1.5. It's hard to break that. But it does say determine the function of D in terms of H. So you really want to solve for a D. So take a second, you can distribute. So 62H and then minus 62 times 1.5. You can quick do a little mental math. Half of 62 would be 31 if you add that on to it. Otherwise, it's called a calculator. So 93. And then D minus 221, and then we can add this on over. So the distance is 62H, and then that is going to turn into 128. Okay, that's your equation for part A. Ooh, good, I didn't fall off the screen. All right, part B. If the total distance from Albany to Buffalo is 290 miles, which I just looked it up, it's like 288.8 on the one thing I found, so that's accurate. Determine how long it takes for Steve to reach Buffalo. So they're telling you if the distance is 290, find how much longer it takes him to get to Buffalo. So find H. So we have an equation. Now we're just plugging in. So 290 goes here. 62, oops, I forgot. We don't know H, so keep that as H there. And then we're going to solve. So subtract 128. And so that's going to give us something, 290 minus 128. 162 equals 62H. And then divide. So divide by 62. And I get H is like 2.612, and it keeps going. All right. Go back to the directions. Round your answer to the nearest tenth. So we're going to say about 2.6 hours. So if you could kind of guesstimate what that is, 2.6, oops, I should keep that as H. 2.6 hours, I don't know, like 2 hours and 30 something minutes, something along those lines. And so you got to keep in mind, he's already been driving for an hour and a half. So he's got another 2.6 hours, they're saying, until he reaches Buffalo. All right. As for the rest of the packet, you can start it right now, or you can wait till class. But I do want you to look through it because, as always, I'm going to want to know, are there any particular ones that you'd like to look at together in class? Even if it's not an actual number in the packet, maybe just a general concept of, I want to practice 3x3 systems or whatever. So go answer that post-video question right now, and I will see you guys tomorrow in class. Thanks.